Welcome to AI CyberTalk, the channel where we dive into everything related to deploying artificial intelligence safely. With OWASP's recent release of the top 10 security risks associated with large language models, LLMs, like ChatGPT, GP4, and Google's Bard, we will explore how improper use can jeopardize your company. Look for our other segments detailing out each of the top 10 LLM vulnerabilities. For this segment, we will focus on the third vulnerability identified by OWASP, which is training data poisoning. Training data poisoning is a vulnerability that occurs when an attacker manipulates the data or fine-tuning process of an LLM to introduce vulnerabilities, backdoors or biases that could compromise the LLM's security, effectiveness or ethical behavior. For example, an attacker could insert malicious or misleading data into the training dataset of an LLM, causing it to generate inaccurate or harmful outputs. This could affect the quality, reliability and trustworthiness of the LLM application and its decisions. To illustrate this vulnerability, let me show you some examples of how an attacker could exploit it. Imagine that you have a competitor brand that wants to sabotage your LLM application that generates product reviews for your customers. They could create fake or negative reviews and target them at your LLM's training data source, such as a public website or a third-party dataset. This would cause your LLM to learn from the poisoned data and generate biased or false reviews for your products, damaging your reputation and sales. Another example is that you have an LLM application that generates summaries of news articles for your users. However, you do not verify the legitimacy or origin of the news sources that you use for training your LLM. This means that an attacker could create fake or malicious news articles and publish them on websites that look credible, but are actually controlled by them. This would cause your LLM to learn from the falsified information and generate misleading or harmful summaries for your users, influencing their opinions or actions. These are just some of the possible scenarios where training data poisoning can pose a serious threat to your security and privacy. To prevent this vulnerability, you should follow some best practices such as: verify the supply chain of the training data, especially when sourced externally, and maintain attestations, similar to the software bill of materials methodology. Verify the correctness and validity of the data sources and data obtained during both the training and fine-tuning stages. Verify your use case for the LLM and the application it will integrate to. Craft different models via separate training data or fine-tuning for different use cases to create a more granular and accurate generative AI output as per its defined use case. Ensure sufficient sandboxing is present to prevent the LLM from scraping unintended data sources which could hinder the machine learning output. Use strict vetting or input filters for specific training data or categories of data sources to control volume of falsified data. Data sanitization, with techniques such as statistical outlier detection and anomaly detection methods to detect and remove adversarial data from potentially being fed into the fine-tuning process. Adversarial robustness techniques such as federated learning and constraints to minimize the effect of outliers or adversarial training to be vigorous against worst-case perturbations of the training data. An MLSecOps approach could be to include adversarial robustness to the training lifecycle with the auto-poisoning technique. By following these best practices, you can improve the security and safety of your LLM applications and their users. Discover more about AI safeguarding by visiting www.aicyberadvisors.com. At AI Cyber Advisors, our team of AI security experts helps businesses tap into the potential of AI but ensure it is done safely and securely, while preserving confidentiality and privacy. We partner with business leaders to craft AI strategies, develop AI opportunities and assess the risks of AI against the OWASP LLM Top 10. That wraps up today's AI CyberTalk. I trust you've gained valuable insights on LLM security. If you found this content enriching, please subscribe and give us a thumbs up. For more information, go to www.aicyberadvisors.com.